So we've done solving linear equations, solving quadratics, solving radicals. Now we're going to look at solving inequalities. So what are inequalities? Instead of an equal sign, that's what we've been used to. So instead of that, we're going to be using things like less than or equal to, less than, greater than or equal to, and greater than. So no longer are we going to be looking at this, we're going to be looking at one of these four things. So what you're going to do is you're going to treat it like an equals. Unless you divide or multiply by a negative number. If you do that, all you have to do is flip the inequality. So for solving these inequalities, you're going to treat the inequalities just like you would an equal sign. The only difference is if you divide or multiply by a negative number, you just got to flip the inequality. So let's do some examples. So example 1. Let's look at 2x minus 1 is less than or equal to 3. So how would we solve this? We'll treat it just like an equal sign. So if this said 2x minus 1 is equal to 3, you would probably add 1 to both sides to get 2x is less than or equal to 4. Then you would divide both sides by 2. So you get x is less than or equal to 2. But that's not how we write the answer. Okay. So what's our answer? Well, it's all x that's less than or equal to 2. You have a choice. Either write it as a set or write it as an interval. Up to you. I prefer the interval notation. Just because I think it's more compact, but it's up to you. So our answer is all x less than or equal to 2, so negative infinity to negative 2 including 2. Okay. Let's do example 2 here. How about 1 minus x is greater than 5? So if you were doing this problem, you're going to treat the greater than as just like an equal sign, unless we divide or multiply by a negative number. So if you were doing this problem, you'd probably subtract that 1 first. So you'd get negative x is greater than 4. Now I got to get rid of that negative, so I'm going to divide both sides by a negative 1. But be careful here, because we're dividing by a negative, you got to flip it. So over here I'll get x, and over here negative 4. So what's my solution? I'm just going to write it as an interval. It will be negative infinity to negative 4, not including 4 because there was no less than or equal to, just less than. Example 3. Let's look at 3 times x minus 1 plus 1 is greater than or equal to x plus 2. So if this was just an equal sign, probably what you would do first is distribute that 3. So 3x minus 3 plus 1 greater than or equal to x plus 2. Then you would simplify the negative 3 and the 1. So 3x minus 2 greater than or equal to x plus 2. Where's my variable? Well, it's on both sides, so you got a choice. Either move the 3x to the other side or move the x to the left. I'm going to move my x. So I'll get 2x minus 2 greater than or equal to 2. Now I'll add 2 to both sides. So 2x greater than or equal to 4, which means x is greater than or equal to 2. So how are you going to write this? I would write it as 2 to infinity. It's up to you. If you want to use set notation, that's fine, but 2 to infinity. Alright, another example. Let's look at 1 over x plus 2 is less than or equal to 5. Now again, the only time you're going to move anything, or sorry, flip the sign, is if you're multiplying or dividing by a negative. Other than that, treat it like it's an equal sign. So if I just put an equals here, how would you solve it? Well, your variable is in the bottom of a fraction, so how do we get rid of it when it's in the bottom of the fraction? you're going to multiply both sides by that denominator. On the left-hand side, it'll cancel to just give you 1. But on the right, you got to multiply it by 5, so I get 5x plus 10. Now what would you do? Well, we subtract 10, so I'd get negative 9, less than or equal to 5x. Then you'd divide by 5. So I get negative 9/5 less than or equal to x. How would you write this as your answer? You'd write negative 9/5 to infinity, including the negative 9/5. Now for all of these, we just had one inequality. You just got to remember, if you're going to divide or multiply by a negative, flip it. But with inequalities, you can actually have more than one. So if you have more than one, so if more than one inequality, just treat the problem like it has 3 sides instead of 2. So what I mean by that is, all the problems that we've done, I've said if you do any operation to one side, you have to do it to the other, because there are 2 sides of the equal sign. Well, if you have more than one inequality, just treat it like there are 3 sides. So anything you do to one side, you got to do to the other 2 sides of the inequality. So let me do probably 3 examples of this. So example 1, let's look at negative 2 is less than or equal to x plus 1, which is less than or equal to 3. So I want to get my x by itself. So if this was just an equal sign, you'd subtract 1. But now instead of just 2 places to subtract 1, we have 3. So I get a 2 here and a negative 3 here. Now that x is by itself, we can write our answer, negative 3 to 2, including both endpoints. Example 2. Let's look at 2 is less than 3 minus x, which is less than 4. So treat it like an equal sign until you multiply or divide by a negative. So if they were equal signs, you would first minus your 3. But remember, there are 3 sides now, so I got to do it in 3 different places. So minus 1, negative x, 1. Okay, now get x by itself. How would you get it by itself? Well, you got to divide by a negative 1. But now remember, there are 3 places to do that, and we want to be careful. That was a negative number we just divided by, so flip my inequalities. In the middle I get an x, on the right I get a negative 1, on the left I get a positive 1. So what's my answer? Well, the smallest x can be is actually over here with the way we have it written. Erase that. Negative 1, and I can't be equal to it. Largest one is 1. So I'll have a parentheses there because, again, you couldn't be equal to it. And example 3. Let's look at 0 is less than or equal to 1 minus 2x, which is less than 2. So if you had this problem and just had equal signs, first you would probably subtract the 1. But I'm going to just do it to 3 different places. So I'll get negative 2x in the middle, a negative 1 on the left, and a 1 on the right. Next thing you do, divide by a negative 2, which will give me just an x in the middle, but be careful, that was a negative number, so flip your inequalities. On the right, negative 1/2, and on the left, just 1/2. So what's my solution? Well, the smallest, I dropped my greater than or equal there, greater than or equal to, the smallest is going to be negative 1/2, the largest is 1/2, and I can be equal to that larger one. So with inequalities, treat it like it's an equal sign, unless you divide or multiply by a negative. If you do that, just flip the inequality. And if you have 3 sides, anything you do to the middle one, you have to do to the other 2.